Hi, everybody. This is Yehuda Holtzman, and I'm glad to host today Yair Shapira.
Hello, Yehuda.
Yair has done a podcast before on 5G networks, focusing on technology and application. And today, our focus is going to be mainly on business models and some interesting opportunities for entities to run networks. We're going to elaborate on that. Yair, maybe as a starting point, let's provide a short review of the main application we discussed in depth in the previous podcast.
Sure. Last podcast we have discussed, I would say, the three applications or services categories that 5G technology and standardization is aiming to support. We have mentioned the first one was enhanced mobile broadband, acronym is EMBB, which is the ability to support high data rates or higher data rates than 4G is supporting. We talk about data rates of 10 to 20 gigabits per second per cell sector. And from user's point of view, the user experience, we talk about data rates that may get to 1 gigabit per second per user.
And the EMBB is sort of an application or capability that replace 4G.
So we talk about data rates which are much higher than 4G provides today, and they are closer or even higher than the data rates that can be achieved with Wi-Fi, or can theoretically be achieved with Wi-Fi. And more specifically with wideband Wi-Fi. We know that theoretically Wi-Fi can be operated today with bandwidths that get up to 160 megahertz. So with millimetric wave, operators can run this channel bandwidths and even more than that. I'm mentioning it because one of the goals, maybe hidden goals of the EMBB is to give a good fight to the Wi-Fi and to replace Wi-Fi in, in public venues, for example, in stadiums or in airports, because at least presumably EMBB will be able to provide higher data rates with higher quality of service than Wi-Fi. The other pillar or the other type of services and applications is the massive machine type communications, the MMTC. And here we talk about the ability to manage huge number of end devices like sensors, like meters, like all kind of equipment that communicate with other equipment. And here there are several challenges, like first, the ability to manage tens of thousands of sensors like that by each cell or sector, and also to run a protocol that enables long battery life. So this is another type of applications that...
This is mainly, as you mentioned, either machine-to-machine type communication or IoT devices. Sensors that can communicate.
Right. IoT or sensors are, let's say, one class or one category of machine-type communication.
Right.
And the applications here, and maybe it's time to mention some applications, is metering, meters reading of sensors, environmental sensors within the buildings, and controlling, energy consumption based, for example, on temperature, humidity, and other factors. This falls into the category of smart buildings, for example, or building automation. There is another type of applications that is behind this category or including this category, and this is the wireless connected factory, connecting devices within the factory, machines, robots, and others. And the third category of applications is called ultra-reliable low-latency communication. And this relates to the ability to provide communication with ultra high reliability, but also with ultra low latency. And classical example for an application in this category is vehicle to vehicle or vehicle to everything. This is the communication that intend to run between cars, to provide all kind of alerts about, a vehicle is approaching a junction, or there is an emergency stop of one vehicle. It needs to inform the other vehicle that there is a sudden stop somewhere on the road. So this information needs to propagate very quickly to all vehicles in the area. So this is a very, let's say, critical and unique type of communication, very different from the type of services and applications that we've seen service providers providing until now. So this example brings us, I believe, to the main topic of this discussion.
Maybe before we go there, last time you mentioned another interesting application that I think is also very unique, using the URLLC, especially because of the low latency portion, and this is AR.
Right, absolutely. And thank you for mentioning this.
Because at least in my eyes, what's unique with this type of application is that it serves locally, meaning, when I'm walking somewhere and I can see in parallel a lot of information about the building I'm crossing, where is the restaurant, and a million other type of information. And then I can see that this type of application will be probably most used in closed environments, such as stadiums, such as large industrial zones, airport. And then there is a potential for a local entity to run these services and not necessarily the operators.
Absolutely. And stadium is a very good example. In the future, and not futuristic, these things are happening now. Future stadium, a lot of information will be delivered to the fans through augmented reality, meaning the fans will see the performance or the game through augmented reality goggles, and through that they will be able to see the best camera that takes the picture at that time. You will be able to see additional information, whether it's statistics, whether it's repeatings of moves in the game, and so on. And all this information is created within the venue, within the stadium. Right. And it is unique to the stadium. It's not information that interests others. So there is a question, if this is so unique to the stadium, and maybe even the stadium owns this information and the rights to show this information, why should the service provider be involved at all if the stadium can install and operate its own network for the benefit of its fans? The same rationale goes to other types of applications. For example, reading environmental sensors in an airport. This is an information that interests only the airport. Maybe even there is a security issue, and the building owner doesn't want even this information to go out of the building. So all of these good reasons actually push us to the direction of private networks.
Okay.
A situation where the venue owner actually builds and runs his own cellular or wireless network for providing wireless services within the venue that he runs, and be able to provide the very unique and different types of services that we see emerging now with the fifth cellular generation, like the IoT, like the MMTC, like the ultra-reliable low latency, and the related services.
How is it going to work? From one hand, I can see the logic, meaning, as you mentioned, information that is local and only the local entity, say the stadium or the airport, cares about, makes sense to handle, especially since there are new application layers that were not available before, meaning that 5G actually created the opportunity to generate them. But since the spectrum is owned by the operators, how are they going to live together? What's going to be the model here?
Right. The spectrum, or the question who is going to provide a spectrum, or which spectrum these private networks are going to use, this is a major question, but there are several answers to that question that I would like to discuss.
So you're saying that, yes, there is this question in case that actually they are using the same spectrum that is owned by the operator, but there might be an opportunity here to use different spectrum for the 5G.
Right, and there are several alternatives that I'm going to mention.
Okay.
The first and maybe the trivial alternative is to use unlicensed spectrum. And it has a big advantage since the entity, the private network, doesn't need to acquire a license for providing services with this spectrum, as it doesn't need to acquire a license for Wi-Fi.
Right.
But it can still use 5G technology in unlicensed spectrum, and the spectrum for the fifth generation includes also several bands which are defined as unlicensed spectrum. So it's definitely possible, and we'll definitely see private networks using these unlicensed spectrum bands. However, we need to remember that there is a drawback of using totally unlicensed spectrum, and this is the fact that there is no guarantee that other entities are going to use the same spectrum and actually interfere with your service. Having said that, we know, since we are talking about, mainly private networks that operate within closed enclosures, so there is let's say, a natural shielding between the inside and the outside. So this may significantly reduce the risk of being interfered by other users. And adding to that, the fact that most of the unlicensed spectrum of the 5G is in the millimetric wave, and we know that in millimetric wave propagation is very low and is very limited. The risk or the danger of getting interference from other locations is relatively low.
Right.
So definitely the use of unlicensed spectrum is a possibility, and we'll see it happen. Another type of spectrum, which is called shared spectrum, or more specifically the band which is called CBRS in the States, is also a good candidate for private networks, and actually this is what we are seeing now. We are seeing equipment which is being developed and then provided to private networks in shared spectrum in the 3.5 gigahertz band, the CBRS band in the States. We'll not get to a full explanation about this band. We'll just say that it is divided, or there are three hierarchies of users in this band. The lower hierarchy uses the spectrum as totally unlicensed spectrum. But there is a middle hierarchy which acquired the license in lower cost. However, he might be instructed dynamically not to use specific channels if it is used by higher priority users. Bottom line, the CBRS spectrum is definitely the first spectrum that we see used now by the private networks. And we see in this context, I would like to mention that beside of private networks that are going to be operated by venue owners in specific venues or individual venues, we see the emergence of new players like cable TV service providers. Charter is a good example for that intends to be private networks operator, meaning targeting the private network market, is planning to use CBRS as the spectrum is going to use, and to offer its services in operating private networks for venue owners. So instead of the venue owners to be concerned about acquiring equipment and planning the system in its own venue, Charter or the cable TV operator will do it for him, will run the network for the venue owner, in this case, or at least at the beginning, with the CBRS frequency band. And maybe for concluding, or last interesting business model that we see emerging now is the hybrid private-public network, where the building owner can actually cooperate with the conventional service provider, create a network where eventually the private network is connected to the network of the service provider, and they make a distinction between two types of information. The one that actually is generated within the building, whether it's information comes from sensors, whether it's information created by augmented reality servers and intended to be used by the venue, again, either by control systems that controls the environment, the energy consumption, or in the other end, provides information to the fans. All this information will stay at the venue and will not be directed to the service provider.
So utilizing the licensed spectrum, but is kept within the premises of the venue.
Exactly. And on the other end, other services, for example, voice services, will be directed to the service provider. So it's a kind of, we may say, win-win situation where the service provider, the conventional service provider, is still involved with the venue, is not, taken out of the venue, but the venue can operate or can run its own data, its own services within its own venue.
Interesting. So to summarize, we gave a very short review of the three main applications. And again, I invite our listeners to listen to the previous podcast on 5G technologies and application. As for the business model, it looks like there is an opportunity, especially when we are referring to the usage of unlicensed spectrum for local operators to run the information, the data, the application that serves that specific location, whether it's a stadium or an airport and so on. And on the other hand, there is the hybrid approach where actually the usage is of the licensed spectrum. The operator is using it for what we call nationwide type application, whether it's voice and data, while the local operator or the local property owner is using it for its own use based on what 5G enables, whether it's AR, whether it's machine to machine, and so on.
Absolutely.
Great. Well, thank you very much, Yair.
Thank you, Yehuda.
And looking forward for next opportunity to see you here.
I'll be happy. Thank you.
Thank you, everyone.